x minus 8 equal to 1. Because you can take the square root of 0 and you can take the square root of 1, but you can't take the square root of 0 minus 8. Okay, now let me try to come full circle with this. If x is 8, 8 minus 8 is 0.
Right.
Okay, and that's all right. That's fine. So, but what if you want it to be 1? Well, again, it's kind of same there. You add 8, x equals 9. 9 minus 8 is 1. That's square root of 1 is 1.
Right.
All right. So the point here is, like, if I give you a problem, if I say like f of x equals 3 plus the square root of x plus 2, okay, you have to come up with some x values that make sense. Like x equals 0 is bad. And the reason it's bad is because 0 plus 2 is 2, and the square root of 2 is unknown. But if x is a 7, for example, it's good, because 7 plus 2 is 9, square root of 9 is 3, and you've got it. All right, so what I'm trying to get you to see here, think about, is like what like numbers work. Okay, so let me give you a much simpler example. Let's just say f of x equals the square root of x minus 1. Give me 2 x values that work, that are nice.
Two and wait. They have to. Oh, that wouldn't work.
2 is good. X equals 2 is good because,
And then it just equals 1.
yeah, and the square root of 1 is 1. That's a good number. That's a good number. That's the
And
point.
then
Yeah,
4.
Okay, say that again.
4.
X equals 4. So 4 minus 1 is 3. What is the square root of 3?
Oh, I meant to. I was trying to do 9 and then the square root of.
So that's the whole challenge here, is you got to
Right.
make the inside part equal to a number that you can take the square root of.
Okay, I'll do 10.
Okay, so if x is 10, square root of 10 minus 1 is the square root of 9, which is 3. That's good. That's good. Okay. Let's make this a little bit harder here. Let's say f of x equals 4 minus the square root of x plus 7. Give me 2 x values that.
Wait, how does the number outside of the. Where does the 4? Okay, wait, I think I know. I'm just going
It
to try.
actually does not have any impact.
Oh, it doesn't.
Right.
Would I.
Like, this is no impact. Just look at this part here. You're trying to make the part under the square root
Okay.
equal to something that is doable.
All right. 2 plus 7.
Yep. So x equals 2 work. That's kind of the low hanging fruit, if you will, because the get to 9. Okay.
Mhm. 9 would work.
Okay. X equals 9 works. Good. Give me I want a negative x value now. Give me a negative number that you know will work.
A -6.
Yeah, -6 is a good one. Okay, great. So I think you're kind of getting this here. Let me see if I can throw up a question from last time, because I think there's just this little disconnect I think we've figured out here. Let me see if I actually can get to that. Hmm. Yeah, so I can't, I gotta go grab it from another way. All right, give me just a moment here to find that. So, yeah, so here was a question we were looking at last time. And I was trying to make the point that when you look at when you try the answers and you look at x plus 10, it's not that you can take the square root of 1, because you can with the square root of 4. It's when you put the numbers in here, can you take the square root of them? And that's what I was hoping you could kind of look at now is there.
Okay, yeah. Wait, so.
Like,
Alright,
when you put these numbers in, does it make a workable square root? That's the whole point of what we're trying to
on
think
it,
through.
okay, yeah. And for them to be workable, does it have to be 0 on both sides?
No, it just has to be the square root of a number you can take the square root of. Like you can take the square root of 0 and the square root of 1 and the square root of 4 and so on. That's what I'm trying to get you to tell me is like before you look at these numbers, like what can you actually take the square root of over here? If x is 6, you can take the square root of 16, but
Yeah,
when x is 4, does it work?
right. I got 6, by the way.
Right. And so I'm hoping that you will be able to do this without like not make the classic mistake of, oh, it's 1 because the square root of 1 is 1. Like, no, that's not right. and uh, work through it that way. So right, let's look at another one here. These aren't meant to be like extremely difficult. They're just meant to emphasize this idea of what can you take the square root of. See if I can find another one here. Yeah, so here's, again, not like look at this problem. It's not a difficult problem. When you look at this list though, what can you actually take the square root of? Which numbers can you take a perfect square root of?
16. Can you do 1 of 64?
Yes,
8? Or what is it?
you cannot do 8. Like, so that's where you got to
No,
know
no,
this
no, no.
list.
I was saying what's
Oh, okay. Yeah. And so it is 8. Yes, it is 8. So good. And that gets you down to 2 answers. Like using little stuff like that tells you, okay, I,
all right, let me solve it.
yeah. So could you try solving this for us, please?
B.
Okay. So the square root of 16 plus 4 equals 12. The square root of 16 is 4. 4 plus 4 is not 12.
Oh, wait. Oh, I see that. Okay, so then let me try 64.
Sure.
Try it. And you said the square root of 64 is 8? Yeah, it's equal.
So for 64, it does work.
Mhm.
And can do that. All right, so next thing here is to look at a problem. Yeah, so we kind of looked at this last time, I think, and this one's got two square roots, so the numbers got to work in both. Like you can't just work in one. It's got to be able to take the perfect square root of that.
All right, let's see. Okay, so I plugged in. What I would do is I would figure out if I could even, I would add it up and then see if it was even possible to square root it.
Right, that's right. So does 8 work? Is 8 plus 28 possible?
Yeah, because you get 36.
Okay, so that's square root of 36. How about 8 plus 1?
Yeah, and same with that.
Right, so that's good. The good news that what that means is that like at least these work. Now there might be more than one that work, but you'd have to decide that. So what is the square root of 36?
6,
6 minus 2 times the square root of 3,
which is
or
3.
square root of 9, which is 3. Give me the answer. So does this work? Is this true?
Mhm.
It is. Okay. All right. Well, feel like let me see if there's any other questions on this. For some reason it seemed like I emphasized. Yeah, so here's kind of another one. This one's a little different, but it's kind of the same. It's kind of the same idea as you got to be able to take the square root of that number. So which of these numbers can you actually take the square root of?
No, you,
And you take the square root of any of these.
no.
Square root of
Yeah,
25
and
is 5.
Yeah.
Okay.
Oh,
So like that is the answer, but
yeah.
yeah, that's why this is this designed this way. It really is. It's like you, you know, um, you have to be able to see, which of those numbers actually work. Right. Okay, so let's pick a new topic here. You're going into geometry, right? That. Let's see what else. What else can we kind of talk about here? I guess we should just do a little bit more on the square roots and actually maybe talking about reducing roots, which we've done, but we haven't done in a while. Maybe we'll do just a tiny bit on that since it's related. So reducing roots, it's something like the square root of 12. Okay. And if you recall, we talk about prime numbers when we talk about reducing roots. You're actually building what's called a prime factorization. And you need to know the prime numbers. You need to know, okay, it's 2 and 3, and then 5, and then 7, and then so on. Okay. Because what you do is you look at the smallest prime number, like what's the smallest prime number that goes into 12?
1.
2. 1 is not a prime number.
1's not, yeah. 2.
Which you might like, why isn't it? We don't have to get into that. I mean, but it's something you can sort of think through if you want, if you're really, we can talk about, but the thing is here is that you start with 2. 2 is a great number to start with, and it's 2 and 6.
Oh, this is where we're, so for, well, I understand the concept. I was just saying the title name, reducing roots, is the idea of making like the whole tree, right?
Yeah, so these are the ones that don't work out nicely. I mean, these are the ones where, we wish they did, but they just don't. So that's okay.
2 and 3.
2 and 3. Okay, and then we talked about this idea that you're going to look for
The pair.
pairs. So there's a pair of 2s, which means the 2 comes out. So it's
And then
2 square root of what didn't come out, which in this case is 3. So that's where we're at with that. What would the square root of like 28 look like? You want to give that one a try?
yeah, 28. So one more question. My idea was going to be to do 4 and 7, but do both numbers have to be prime?
You always start with 2. Always start with 2. Don't get ahead,
Okay, can I do 2 and 14?
What do you mean by that? Yes, yeah. So you start with 2. It's like you try until it doesn't work.
Got it. So 2, 14.
Yes.
And then from 14, you can do 2 and 7.
Yeah.
And then circle that up. 2 on the outside, 7 on the inside.
Yeah. All right, good. So the idea here is that, you try a number until it doesn't work, but it's not always that you start with two. If you get a number like 45, well, two doesn't go into 45.
I could do, oh yeah,
So what is the next prime number to try?
3's prime, right?
Three. So you start with three. If two doesn't work, go to three. And then you keep trying three until it doesn't work.
3 works, right? 3 and
Okay. Yep,
15.
3 and 15. Good. And then
3 and 5.
3 and 5. Good. So what is your final answer?
3 on the outside, 5 on the inside.
Yeah, 3 square root 5 is how you would say that. So good, 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 good. All right. So you can actually have more than two numbers, come out, or more than one number come out. We've talked about that idea. Let's talk about like the square root of 72. And so I want you to start with two, go as far as two will take you, and then move to three.
Got it. Okay, I got it, but I'm confused how I would write it out.
All right, so 2 and 36, 2 and 18, 2 and 9, and then 3 and 3. Is that what you have?
I did. Oh wait, yeah, no, I see what I did. I remember what I did.
Okay, so you try it until it doesn't work. I mean, I'm
So I
assuming now just
did 2 and 36, and then 3 and 12.
right. And while that works, you have to try that number until it doesn't work. Like that is the algorithm.
Got
Um, maybe so if you're more of a tinkerer in your own life, I call a tinkerer a person that they're always trying something different. Maybe every time you go to Chipotle, you try something different, or you like, I mean, I'm very much like, one path, linear.
Right.
It works, do it again, do it again, do it again, do it again. But you occasionally get around these people that there's nothing wrong with that. It's just in math here, it's very programmatic. It's like, do it, do it, do it. Okay, it doesn't work, so do something different. You circle the pairs, and when there's more than one pair, okay, they both come out and you multiply them, and you take the square root of what's left over, which is 2. So this becomes 6 square root of 2. Now it's also possible that you have more than one number on the inside. Okay, so let's look at the square root of 60. So this becomes 2 and 30, 2 and 15, 3 and 5. Okay. So you have a pair. Great, got a pair. Pair comes out 2 square root 3 times 5. 3 times 5 is
15.
15.
I see that.
Good.
Nice.
Very
Okay, that
good.
makes
Okay.
sense. Yeah.
All right.
Hey,
So I've got some more. Good. Yes,
and
questions?
I need to step away just for a second. Our house cleaner.
Yeah, yeah. Take as
one
much
second.
time as you need. Just let me know when you're back.
I just gotta let him through the garage, and I'm right there. So I'll be right back. All right, I'm back and ready.
So let me get up some of these worksheet problems for the Fed. The numbers are gonna be a lot larger. So if you need to grab a calculator to be able to do these, that's fine with me.
All right, sweet.
Let me get the. All right, so while I'm fumbling around to get there, let's gotta click on a bunch of links here. All right, so let me just here try this one. Square root of 180.
All right, I got it.
Now, what's your final answer?
Oh, okay. Wait, how? I need one more reminder on how to like combine it. So I have my two sets of twos. But no, I
Okay,
don't.
so if you have more than one pair, we covered that, you multiply them on the outside. If you have more than one number left on the inside, you multiply. You gotta
So
take
it's
a leap
12,
here
12 and 5. 12 square root 5.
like this.
Yep.
Okay, so this is not correct. Tell me your first branches here. What did you have?
2 and 90.
Okay, that's correct.
2 and 45.
Okay, that's correct.
3 and 15.
Okay, that's good.
3 and 5.
Okay, so you circle the pairs. Now, did we ever bring more than one number out from the pair?
No.
So you bring out a 2 and you bring out a 3. So what goes on the outside?
6.
6 squared 5 is correct. All right. Okay, so new one here for you to try. How about the square root of 420?
Five is prime, right?
5 is prime, yes. Stop when you get a 5.
Okay. So 2 on the outside. But then I have 2 numbers down on the bottom that are prime. Would
Okay,
I
so,
multiply them or just
well, what did we do in this problem?
you multiply them out?
Yes.
So 2 square root 21.
Like this?
Yeah.
Okay. This is not correct. So give me your first separation here, 2 and,
210.
okay, and then 2 and,
105.
okay, does 2 go into 105?
No.
So you try 3, does 3 go into 105?
Oh, you have to go to that's where I messed up. I just went to,
You
I
have
went
to go to 3.
5.
You have to do it in order.
Yeah, I forgot about that.
First base, second base,
Yeah,
third
3 works.
base.
3 and 35.
Okay, and then
7
3
and
to
5.
5 and
Or-
7.
Yeah.
So what number should go on the inside? 21.
35.
It's these three numbers multiplied together.
Oh, those three. I just called them two. Okay. 105.
105, good. All right, so it's 2 square root 105 like that. All right. Let's try a couple more here. How about the square root of 216?
Two square root 27.
Just redo this problem. Really, I mean, something is happening here. Like you've got to do the numbers 2 until it doesn't work. Then you try 3 until it doesn't work. Then you try 5 until it doesn't work, and so on. Just restart it. Sometimes you just flip the paper over and you just say, all right, I got to redo this. This isn't going well.
Well, I think I solved it the right way. I think the way that I'm writing it is wrong because, well, I'll redo it, but I think, yeah, the way that I am writing it out is the wrong way.
Okay.
But yeah,
What
I'll redo
two and what number?
2 and 108,
Okay. Now what?
2 and 54,
Okay. Now what?
2 and 27,
Okay.
3 and 9,
Okay.
and then 3 and 3.
Okay. So you actually have all this written down on your paper.
Yeah.
Did you circle pairs next?
Yes.
Okay. So there's a pair and there's a pair. So I asked that because the only number you brought out was a 2, but there's a pair of
Oh,
3s.
so 6 on the outside.
Okay. And what's left over on the inside? Two and 3. You got the 2 you didn't use, the 3 you didn't use. Both of them come inside because they're not used up. This 2 is not like I do my laundry once a week. If I have 3 socks, which I pray never happens, I can only pair these up and I got an extra one. Well, I got to do something with it. Well, you put it back. I had 3 3s. I can pair up 2 of them. That other one's got to go on the inside here. So what does this become?
6.
Square root of 6. Okay. I know this is maybe, well, I don't know. My perception is this is kind of painful, but we can do this. Like this is not impossible.
Yeah.
And I don't know if you're truly doing all this, maybe you just aren't circling the pairs. You can say use boxes for the other ones. I mean, I don't care. Like whatever you know, it's like I don't care how you run down to first base as long as you get there before the ball does.
Yeah,
So
exactly.
just you gotta make a path here for yourself. So go ahead and give this one a try and let me know what you come up with.
3 square root 50.
Like this? Is this what you have?
Yeah.
This is an intermediate answer. So it's not like wrong, but it's not the fully reduced answer. So let's do this again. Tell me what your break apart here is.
225.
Okay. And then what number did you use next?
375.
Okay, that's good. Keep going.
325.
Okay, that's good.
And then 5 and 5.
Okay. So like to me, like this is like I don't you know, I got a blue sock, a green sock, a green sock, a red sock, and a red sock. Like what am I pairing up?
The 3 and the 3.
Anything else?
Can the 2 on the bottom get paired?
Yes, yes.
Oh.
Okay, so there's the disconnect. You gotta, yes, I mean, eventually the branches stop, they stop splitting, so yes. So the 5 and the 5 comes out, a 3 comes out, what stays on the inside?
The 2.
Okay, so give me your better answer, we'll say.
15 square root 2.
Good, really good. Okay. All right, let's do one more. The numbers, unfortunately, they just get monstrous here, but it's totally doable. Square root 810. Square root of 810. Try that, please.
There we go. Pair. 3 times 3 is 9. Okay, 9 square root 6.
Like this.
Yeah.
Okay. Close. Let me just write, so 2 and 405. 3 and 100 and why am I struggling here? 135? Does that look right to you?
Yeah.
3 and 45. 3 and 15. 3 and 5. Does that match what you have?
Is 3, why did I get 20? No, because I made this error. I don't even know how I did that.
Okay, so based on what you see here, give me take your time and give me the final answer on this.
I had Oh, wait, for the one that is on your screen?
Yeah, yeah. I
Okay,
mean, this
yeah,
one's
yeah,
correct.
I
So,
can do that, I can do that. Okay, so that's 2 pairs of 3,
okay,
so 3 times 3 is 9,
okay,
and then 2 times 5 on the outside is 10.
very good. Okay. Now I'm going to really quickly show you how I was checking these because you might think, well, how is he knowing this? What I do to check them is I square the first number and multiply by the second number. So 9 squared is 81 times 10 is 810. There's 810. 15 squared is 225 times 2 is 450. Now this doesn't work to do the problem really, but it does work to check them. So that's how I was, able to verify, that's where I was able to recognize your solutions being right or wrong pretty quickly. 6 squared times 6, 36 times 6, which is 216, and so on. That's one here. 2 squared is 4. 4 times 105 is 420. So that's a kind of a nice check when you're
Yeah.
wanting to make sure you've done it right or wrong. So something to think about. All right, let me go ahead and stop the recording here, and we'll just talk.